So you have found yourself today at why machine learning for anti-money laundering may do more harm than good. I hope you're interested in anti-money laundering or machine learning or both. If you aren't, this might be a boring 30 minutes or it might be quite interesting. So let's see what happens. So for those of you that want to know what's going to happen today, we'll go through a couple of intros and housekeeping real quick. We have a few polls for you. If you don't know Toby, we're going to introduce you to him. Then we're going to go through a quick guide to machine learning with AML. And then at the end, we'll have time for your questions, but you can ask those throughout. So introductions and housekeeping. If you haven't noticed already, no one can see you. I mean, you can see me, but I can't see you. So right now I'm talking to a screen, which is a little strange. I feel like I'm talking to myself. So if you have noise, kids, guests, loud music, none of us can hear it. So that's fine. Also, afterwards, we will send you these slides. We will send you a link to this webinar. And if there's any questions that we didn't get to, then we will answer those as well. And we also have a few articles to send you if you're interested in reading more. So who is Sal, or what is Sal? We kind of explain it like this. So Toby, who you will meet soon, Toby and Jeff are both data scientists at Skype, where they worked on fraud. So they learned to fight financial crime at a massive scale all over the world. Then both of them moved to TransferWise. Jeff headed up the analytics guild there, but Toby dived into compliance at an even deeper level. So he was the global lead of compliance for TransferWise, which meant anti-money laundering, extra due diligence, simplified due diligence, KYC, verification, fraud, chargebacks, you name it, he was in charge of it, which meant that he learned really, really fast because TransferWise kept launching new currencies at that point almost every few weeks. So he learned about these things called audits and auditors and how to please people from all over the world. So taking all this expertise, where they also met Sergey, who is our CTO. Then what happened is, and he was the engineering lead in verification at TransferWise. So then they packaged all of that knowledge, all of those learnings, and they said, we want to help other companies, other banks and fintechs all over the world fight anti-money laundering like we've learned. And so they took the experience, they packaged it, and now that is Salve, which is the anti-money laundering platform that we offer. So this is us. Don't need to dwell too long on that. Basically, I'll be your host. So all you can know is that I'm a research nerd and I'm a pretty curious human, which is how I got volunteered to host this. And Toby is basically a maths nerd. He thinks in data formulas all the time. It's really fascinating listening to him, but you'll hear more about that later. But he is the CEO and co-founder at Salve. There's this little button, or should be, at the bottom that says Q&A. So you can ask a question at any time. And if you have any of those questions, we will try to pick those up at the end. So we'll start out with a couple of quick polls. The first of them is for you now. So hopefully you should be seeing some polls pop up on your screen. There it is. So if you are an AML professional, what would you say is true of your company? Do you use machine learning a lot? A little? Are you considering it, not considering it? Maybe there's not enough information, or maybe you're just here because you wanted to learn more, but you're in none of these fields. So yeah, if you can take a couple of seconds to answer that, we'll look at those answers here in a second. Okay, and while you are answering that, when it comes to applying machine learning to AML, what is the biggest challenge for your company? This is something that we asked on LinkedIn prior to this. So I just pulled in all these numbers and I was really fascinating. I was imagining that people are going to say that they don't have enough data because we'll learn a little bit more about that later. But unless you have at least 500,000 active customers, you probably don't have yet enough data to apply machine learning. But most people said not enough quality data. And I do understand that data wrangling and data cleansing is a huge, huge deal in many companies. So that makes sense as well. And then not enough expertise, which, yeah, to do supervised machine learning models, you will definitely need that. So that was interesting. So let's see if we can close out our poll. Do we have answers? Let's see. Okay, interesting. So from our votes, the highest one is that considering it. We don't use machine learning, but are considering it. And then there were around 30% said we use it a little bit. Okay, so then I think you are in the right webinar because I think you're going to learn a little bit more today. So yeah, thank you for that. So let's go into Tobys' story. So Tobys, are you here?
Yes, hello everyone.
Okay, so you can't tell from this photo, but Tobys is extremely tall. So if you stand next to him, chances are he'll be looking up. I know I am because I'm quite short, but yeah. So Tobys, I understand that you were working in as a data scientist in fraud at Skype. So I imagine, did you use machine learning a lot?
Not a lot actually, although I was doing my PhD studies back then, which was around machine learning and neural networks, hidden Markov models. So I wanted to use them a lot for the fraud detection back in Skype. But it was pretty difficult because first problem was that these algorithms weren't that advanced back then. And like over the last 10 years, machine learning has done like great evolution. And secondly, computers were pretty slow actually. So it's like to process millions or billions of transactions, we didn't have powerful computers in the company or nowhere in the world to run these complex models. But they look pretty promising.
Huh. Interesting. So then, like, what I'm understanding is that you wanted to use them, but they just weren't as advanced as they needed to be back then. Is that correct?
Yes. It was like a clearly good research topic for interns and myself to study how to run this large-scale data mining using some intelligent learning algorithms. But the paradox was that we had a super clever engineer, Argo, who was also helping us to build Salve in the first hand. And like with his logical non-machine learning rules, the performance of the fraud detection was as good as neural networks. So it wasn't the real need or real business case to go into this more advanced technology. And only like in these days or in the current days, machine learning is getting to that level where we had the rule-based logic back then, like 10 years ago. So machine learning has done great evolution, and today I would prefer to use machine learning algorithms for fraud detection at least.
Oh, interesting. Okay, so you think that machine learning is definitely ready for fraud at this point?
Yes, I've seen a great evolution over the last 5 years, especially. A lot of good companies are coming up who are doing fraud detection using machine learning techniques. And as an expert in that, I see that it really makes sense. So they have a lot of training data, they have a lot of customers, good algorithms. It's like the fraud problem is getting more and more resolved by these intelligent machine learning based technologies.
Okay, interesting. So, so because you'd already been kind of experimenting in machine learning back in fraud, like in Skype, did you try to then, I mean, since machine learning was advancing all the time, did you try to apply machine learning when you came to TransferWise in any of the areas?
Yes, it was like in parallel with many other options. Like I was trying to, as TransferWise was growing really fast, and the complexity of the product and complexity of the markets and customers was really, really large. Then originally I was trying to use my 3 methods, which I had studied, and I had been thinking about that I would like to use for the crime detection, not only fraud, but also for the money laundering detection. So I tried to use it in TransferWise, but it wasn't that successful in the beginning, at least.
Okay, can you tell me maybe a story or two when it didn't go well and why, maybe in money laundering?
Yes, there were like many reasons. There were technical reasons. We didn't have enough training data because like machine learning algorithms need a good amount of data. For early phase startup, it wasn't enough actually. Regulators got confused when I was talking about neural networks and some black magic or black box based solutions. My team was struggling to understand why the heck these alerts are coming up if I wasn't able to explain. So that was like pretty, it created extra work in addition to crime detection. The crime detection itself maybe would have worked, but all these other dimensions made it much more difficult to use these kind of technologies.
Yeah, so that makes sense. So like, especially at the beginning, like TransferWise was too early and there wasn't enough data basically to train the models, and then regulators would get confused as well.
Exactly, these were the two main reasons. And really, like maybe the third one was also that I really, as this money laundering detection was really new for me, I didn't know what I should model, or like every modeling should have some goal or some KPI to optimize against. And if you don't have this parameters that you want to optimize and you don't know how to define, so it was like lack of my own experience and knowledge back then, why I couldn't use just some random intelligent technologies to run the stuff, because I didn't know too much about AML itself actually.
So even though you knew a lot about machine learning, because you didn't have a depth of enough knowledge in AML at that time, then it didn't work very well.
Yes, exactly. Because like in the fraud, it's very clear. You want to minimize chargebacks or financial loss without losing too much in the customer transaction success rate. So like you want to keep the good customer transaction rate high enough, and you want to keep fraud losses low. And this you can play around with these two parameters quite successfully. But in the AML, the question is like against what you're optimizing. It's like this in itself is like a really long topic. You can look back to the KPI discussions we have had, and like there are tons of different parameters that you should measure to understand the success of your AML product performance process. But how do you put these 10 different parameters or 20 different parameters into machine learning as a target optimization goals? That's yeah, pretty complex topic.
Yeah, that makes sense. Well, I don't want to run out of time before we go into kind of helping our audience. So we put together kind of a really, really basic course on anti-money laundering and machine learning. And of course, this is super simplified. We have way more stuff on this, but I just listed them off on the screen so you guys can see them there. But I don't know, Tommy, if you want to, it looks like we have a couple of minutes. If you want to talk about, I don't know, maybe some of your experiences or stories with some of these.
Yes, it's like quick course. There are several pros and cons that we or you need to consider when thinking if and when and how to use more intelligent technologies when it comes to machine learning and applying it in the ML world. So first of all, the positive thing is that if you have a really strong team who knows a lot about AML and techniques that they want to apply, you have really high quality data, you have access to this data, detailed information, you have you clearly know against what you want to optimize. Is it like higher detection rate? Is it higher cost, lower cost of the team? Is it being compliant? Then it's like if you have settled the problem and you have the tools and technology and people, then it kind of makes sense to use machine learning to optimize, to do the customer segmentation, to forecast the risk level, to do these things. But if you're missing actually understanding of the end problem that you're resolving, or if you're missing access to good data, then trying to use machine learning, then you will screw up everything. Like in this case, I would really recommend to use much more simplistic approach. Because like many people from the bank, senior people have said to me that they are really embarrassed how low level quality they have in their current models. And in this case, machine learning wouldn't help, like because the
So
models.
what do you mean by they have like low level quality in their models? What does that look like?
Well, basically, it's like their teams or people don't know too well what to write into rules or what are the rules that they should use or based on what conditions they should actually find criminals. So there is a basic simple check that has this customer sent more than 10,000 euros over the last week, and that's it. Maybe that's already indicating the high risk, but the people understand that actually it's not too smart check, and I should do something more intelligent, but I don't know what to do. Then in this case, it's super hard to take a more intelligent algorithm and tell the algorithm to do something for me if I don't know what I want to optimize against. And like what. So like still, the assumption is that your team is smart enough that almost they could do this thing manually, or they know very well what to do, and then they apply like hidden Markov models or neural networks or some Gaussian models for that.
Okay, so and then also I understand that I remember reading a statistic somewhere that one guy said it took him like a year to clean up their their bank's data in order to get into machine learning model. And I remember talking to an executive recently at another bank, and I think that took them 1.5 years or 2 years, and it's still not at the right point. Why is it that if your data is so messy that machine learning doesn't work?
Well, it's there are detailed it goes into very technical level sometimes, but it's like you don't have a nice big data table that you can imagine. I have all the customers and all the transactions and all the logins and the whole history in one Excel spreadsheet or in one CSV file that I can upload into my Python code and run it. Usually these events, life cycle events of the customer are stored in very, very different places in different timestamps. The format is different. It's like really hard to bring these data points together. Maybe bank transactions are in one system, card transactions are in completely other, and you need to spend months and months actually to bring these two data points together. And like so on and so on, like every additional dimension or like service that your bank or fintech is offering. Maybe also every different region, like in the banks, like banks are usually built up by the multiple smaller companies, which all have their own IT systems. To bring everything together to build this holistic data set that we can analyze, it's super complex, and usually people underestimate that. Like they think that, okay, data is somewhere in a database. If I get access to this database, I can run all the complex, nice algorithms. Of course, when you're in that phase, then it's super fun and easy, but you need to do a lot of work to prepare and to understand what are these data points and where they are. Is it real time? Is it non-real time? And even like once you have built up the models on the Python, on the CSV file, then someone needs to take this code and put it to live, somehow to live system, to use it actually for the real operational work. And this in itself, again, is like a massively complex problem. How to speed up, how to install, how to get access to the live data, and so on, how to make automated decisions. So that's like a latter part, which is even maybe more complex than the data gathering.
Huh.
So,
oh, sorry, you can continue.
Yeah, just to carry on, like there are a couple of other aspects that I just wanted to talk through. So cannot be left unsupervised. So the main thing is that if you're running your algorithms, machine learning algorithms for the fairly complex customer base, and maybe you have some labeled suspicious cases or labeled criminal cases that you can use to teach or educate your machine learning algorithm. So that I remember that in one of the customers that we were working with, a couple of suspicious cases were related to network of people who, like individuals, sent a lot of money between each other. So there was like 20 people or 30 people, and they were just sending money to each other, and like money came in, it was spread between different accounts, and it was joined together and it was sent out. So these are a couple of cases which looked really suspicious. And then the machine learning model, of course, learned that this kind of behavior is suspicious. And next day, it started to trigger loads of new alerts, which like new cases, which the machine learning algorithm thought were suspicious. And of course, most of these alerts were false positives. They were not actually suspicious cases. And when we went in and analyzed manually what was the case, then we figured out that the original training data came from Europe, where this large groups of people sending money is not very usual. But these cases that the algorithm picked up, it happened in Brazil, where there are big families and a lot of big communities, and they're spreading money between themselves. It's completely common for them to do that. But this pure machine learning algorithm didn't know that, because like we had trained it based on European family and like community models, which were not applicable for Brazil. And again, like this required heavy manual input to teach them that for Europe, use this kind of models, for Brazil, don't use this kind of models. Okay. There's like constant improvement that's required over there.
So it sounds like, yeah, so training data is really important, but training data based on even that region or customer segment, because probably what's normal for car transaction is not going to be normal for a bank transaction, or what's normal for business won't be normal for consumer or trade, and vice versa. Is that why it can't, like, I've heard just basically the dangers of unsupervised machine learning models are pretty high. Is that kind of, can you say more about that maybe?
Yes, it's actually it's pretty generic statement, but it's if you know really well where do you want to use it, like unsupervised learning, like in the AML world, you don't have core evidence that this is a criminal case, and you suspect that this is suspicious, but is it suspicious enough to teach to a machine that, hey, please try to find all these cases, or shall I leave it completely open for the machine, and shall I tell that I don't educate you or I don't supervise you? Just find me anything that looks strange. And usually when I run these models myself, I usually, the unsupervised models which search for the most unusual customers, most unusual behavior. And of course I found these people who didn't look anything like people before, which originally felt that yes, we have found some potential crime cases. But again, when we started to investigate, then we realized that, okay, these are just unusual customers, and these are, everyone is different, of course, like, but these are like people who are running the businesses and are maybe at school still, and maybe they have families, and there is a mix of profiles, and this is already unusual enough that unsupervised model would detect that, okay, I should alert this, and someone needs to investigate. So again, like it's in these kind of scenarios, these unsupervised learning models, they provided interesting results, but that wasn't clearly enough for the operational work.
Yeah, so it's like it got you unusual cases, which was kind of fun to dig into, but if it was a waste of your time and it was false
Exactly.
positive, fun for PhD, but not so much for.
Yeah, exactly. And this takes us to the next point, which is like actually models, machine learning models work pretty well when you have homogeneous, quite homogeneous user group, like similar products, similar markets. Like if I'm running model for like German lending company, which is focusing only on German market and there's one lending product, then of course, and then maybe they're not growing more than 10% a year. That's pretty homogeneous data set, and it's possible to train models and educate them. But if you're launching new countries, like 10 new countries every year, you're launching new products, new like regions, like if you think about the money laundering scenario, which is happening between Moscow and London, we read that some money is being sent from Moscow to London or to Paris, and we learned based on this data. But next year, when I'm opening my some accounts or markets in Africa, then human trafficking between Africa and Europe, and how the money is moved and how this money is split is like something completely different. And I cannot, I need to start it from scratch again. And that's why we're this changing data set and the evolving data set, new dimensions. It's making putting more and more effort on the data science people to figure out. So in these cases, it's like I remember another example when we opened Singaporean market, and we have very few customers, and we had very few, so close to zero suspicious activity alerts, because all the suspicious activity was happening somewhere else. And then regulators said that, okay, regulators in Singapore, auditors in Singapore said that, come on, you should find some suspicious activity from here, because you're regulated here, you must have something suspicious over here. And we said that, come on, we don't have anything. Like we see that strange things are happening in South America and somewhere in Europe, but not here in Singapore. But it wasn't enough. So machine, although maybe it was smarter than people, or maybe it was just underestimating the risk of Singapore. So again, we had to dig in manually to find out what regulator is expecting us to report and what is really potentially suspicious case over there.
So basically, especially when you launched a new market, because it didn't have enough like understanding of that, then it sounds like it kind of gave your team like a false sense of security that things were okay, when actually you needed to spend time a lot manually, like figuring out what does suspicious look like in Singapore, for example.
Exactly, and it's like mentally it was really hard to accept or like realize what is going on. Like, are my machine learning models that I'm testing, are they stupid? Like they are focusing too much on existing markets, which is true. Is my logical rule-based engine too weak, and I'm not intelligent enough to find manually suspicious cases from Singapore? Or is regulator maybe overreacting, and maybe I'm correct and they're just expecting me to report more? but there isn't the reason. So it creates this kind of moral, intellectual dilemmas even for the team members. And again, like without if your team doesn't know well enough about machine learning technologies, weaknesses and strengths, and if they don't know, or if they don't know enough about money laundering and the regulatory expectations, then it's like very, very high risk that I'm overly trusting the intelligent AI technology because machine is smarter than I am and it tells me what to do, but it might take us to the completely wrong position. So in this case, I wouldn't want to use too many of these machine learning algorithms. Actually.
Okay, that makes sense. It looks like we're pretty much running out of time, but this has been really fascinating, and we'll have some more articles for you guys if you want to dig in more. But let's see, move to the next screen. So it looks like we have at least one question. Then also, apparently, if you want to ask a question, you could. There's a little wave button at the bottom, and you can wave, and then Tina will unmute you. But there's one question already that said, you mentioned with less than 500,000 clients, that's what I said, that machine learning has no point. Is that a hard figure, or can there be cases when you can still benefit from machine learning even with less than 100,000 clients?
Yeah, it's this 500K is just illustrative number. The point is that if depends on what you want to do actually with this machine learning. If your goal is to segment your 100,000 customers into groups, like I don't know what are the exact groups of my customers, like who are the people, expats and students and the retired people and so on. And I just want to let intelligent algorithm to learn from my 100,000 or from my 10,000 customers what are the segments. So maybe the goal isn't even about AML in itself. Then it works pretty well. Or if I zoom further into details, like if I want to analyze what are these customers writing to my customer support over the email, and maybe I have some suspicious customers and some non-suspicious customers, and I want to do some text analytics to figure out, okay, what are the specific words or acronyms that suspicious people are using more than the normal people? Because like the hypothesis that like some people who are highly suspicious, they might not have English as a native speakers, and then maybe they have some buzzwords that they tend to use. So I'm using some text analytical, again, machine learning algorithms to figure out, can I model the suspicious emails from customers versus non-suspicious emails from the customers. So definitely these kind of applications are there where machine learning can be used and should be used also for the smaller sets of customers, but it's like holistically, if I'm thinking that, yeah, I have customers, transactions, and I want some machine learning to find all my suspicious transactions from this data set, then you need to be very careful, like, okay, do I have enough data to train the models? Is this data too diversified between the regions, products? Maybe I have single, very, very homogeneous group of customers and transactions and products. Maybe also like maybe even 10,000 is enough actually. But if the customer network is spread around the world, products are very complex, then it's not enough. So that's why it's 500K, don't take it as a rule of thumb, just take it as an illustration of I have enough data or not enough data.
Okay, that makes sense. I haven't seen any other questions come in, but again, feel free to write us. And just kind of as a last question while you're here, there should be a poll that comes up of what would you be interested in hearing about next from Sal. And you can pick as many as you want. All right, so thank you for answering. I guess we've kind of run out of time for today, but if you want to contact us, there's our information, and there's a full blog, which will also send an email after you. It's a guide to machine learning for AML. So thanks for coming, guys.
Thank you. Bye.